To finish out our examples for substitution, one last example here, the integral of tangent. And so you might be looking at this and thinking that, well, there is nothing to substitute here. Well, we're going to use a trig identity, the fact that tangent is equal to sine of x over cosine of x dx. And we have to say, all right, how is that? That's somewhat better because sine is the derivative of cosine, and cosine is the derivative of sine with a strong ish in there. There's a negative involved somewhere that you just got to be careful with. All right, so which one do we want to use? And I encourage you to really encourage you to just pause this right now, give it a shot on your own, and see if you get it right. So let's do it. I'm just going to say, you know what? Cosine of x is in the bottom, so it's kind of trapped in the bottom of a fraction, 1 over u being the function. It's kind of trapped in, so we'll try that one rather than the top, sine of x, which isn't really trapped inside of anything. So u is equal to cosine of x du dx is then equal to negative sine of x, which gives us that dx is the same thing as du over negative sine of x. Using this substitution, our integral becomes sine of x over u du over negative sine of x. Reduce away. That negative just pops outside, and our integral becomes negative 1 integral of 1 over u du. So we ask ourselves, what has the derivative of 1 over u? We haven't really talked about this one yet, but ln of u has derivative 1 over u. Noting that the inputs for natural logarithm have to be positive, we'll slap an absolute value around there and a little bit of a hand wave here, but saying, okay, 1 over u is the derivative of ln of u, so this derivative could be thought of, this integral could be thought of as negative 1 times ln of u. And I'm using the absolute value bars there because in this function, 1 over u, there's no real restriction for u except for u can't be 0 because no division by 0. However, whenever we're talking about ln of u, we have to have a positive input. So we're going to put those absolute value bars around there to ensure that it is positive. Now we're doing an indefinite integral, so plus c, but we can't leave our answer in terms of u since it was x originally. So we'll reverse our substitution. So it'll be negative 1 times ln, which is negative ln, and our substitution was cosine of x for u plus c. And we just integrated a tangent. This is a good exam question. Should show up on pretty much every exam. So just in closing, the one kind of caution here is whatever method you use with respect to substitutions, just make sure you're evaluating your integral. And so there should be the word definite integral here. But it works, this applies to indefinite as well. If you don't forget to back substitute, you'll be giving an answer in terms of a different variable than which the question was asked. So always make sure that you give your answer in terms of the correct variable. Or if you're doing a definite integral, that you're evaluating in terms of the correct variable or making the substitution.